This is Mrs. Nasland, and today we will be looking at Unit 4, Lesson 2, Rotations and Rotational Symmetry. Our learning target today is I can demonstrate an understanding of rotations and rotational symmetry. The vocab we will be looking at today is what a rotation is and what we mean by rotational symmetry. I'll define both these terms as we go through the lesson. First, let's take a look at this square. I want to show you what I mean by when I rotate something 90 degrees, 180 degrees, 270, and 360 degrees. I also want to show you what I mean by clockwise and counterclockwise. So let's look at this shape. I want you to focus here on this point. And I'm going to rotate it first 90 degrees. Now remember, we talked about what 90 degrees was in lesson 4.1. This side here is a 90-degree angle. So we're going to rotate this just one corner turn, or quarter turn is another way to put it. So I rotate it 90 degrees. My dot is now right there. Now if I rotated another 90 degrees, if I do 90 plus 90, I've rotated it 180 degrees. I'm going to go ahead and rotate it one more quarter turn. And now I'm at 180, and you'll notice they're exactly opposite of each other in this case. Now I'm going to rotate it another 90 degrees. So 90 plus 90 is 180, plus 90 more, oops, almost there, plus 90 more is 270 degrees. And lastly, if I rotate it one more time, now I'm back to where I started, and I rotated it 360 degrees. There's 360 degrees in a complete circle, so I'm back exactly where I started. Now the other point of here is something that's called, we look at clockwise versus counterclockwise. If you think about the clock, the hands on the clock go this direction. We call that clockwise. If we go the opposite direction than the hands on the clock, this way, we call that counterclockwise. And I always tell my kids, the clock is always in the room. So if you're ever questioning, is it clockwise or counterclockwise, which way do I go? Look at the clock in the room and you'll be able to remember, oh, the clock is moving clockwise. So that's a good little trick to remember which way is counterclockwise and clockwise. Now rotation, again, that's one of our vocabulary words. A rotation is a turn, a number of degrees, and a direction, either clockwise or counterclockwise describes the turn. So basically any turn in an object is a rotation. So in this one it says, circle the answer choice that shows a pencil after a 90 degrees counterclockwise turn. So again, I'm going to think about the clock. I'm going to think, okay, if I was going clockwise, I'd be going this way. Okay? But in this case, I'm not going clockwise. I'm going counterclockwise. I'm going opposite of the clock. So my pencil is going to rotate that direction. And I'm going to think, okay, if I turn this pencil one quarter turn or 90 degrees, which choice is it going to be? Is it going to be pencil A, pencil B, or pencil C? Again, I'm going counterclockwise, one quarter of a turn. I'm going in this direction. And you got it, it's pencil C. It's this pencil right here, okay? Counterclockwise, one quarter of the turn, 90 degrees. All right, now I'm looking at this figure. All right, it says circle the answer choice that shows the figure after a 270 degrees clockwise turn. So again, I think about my clock. Remember that the clock goes this direction, so my rotation is going this direction, and I want to go 270 degrees. So I always just think of those quarter turns. I think, okay, a 90-degree turn would be facing right here. If I did another 180-degree turn, it would look something like this one here. And now I want to go one more 270-degree turn. What do you think? Is it choice A, B, or C? For those of you who said B, you're correct. It went 270 degrees clockwise. All right, so you're getting the hang of it. So we did a couple of examples. You get to practice those on your homework later on today. All right, now another vocab term that we have is called rotational symmetry. And what rotational symmetry is if you can turn an object about its center and it can fit exactly on itself in less than one full turn. So remember, one full turn is 360 degrees all the way around. If it fits exactly on itself before it hits that 360 degrees, we have what it's called, it has what it's called rotational symmetry. So we look at this little figure here. I look at this figure. If I turned it one little part here, it's not even quite 90, it's about 45 degrees. It'd be right here. And if I go one more 45 degrees, it fits right on itself again. And that's a square. A square has exactly 90-degree rotational symmetry because the first time it fits exactly on itself is after that 90-degree turn. Okay? So for each of these figures, we're supposed to decide, does it have rotational symmetry? And if it does, the number of degrees in the rotation it took for it to fit on itself. So I look at this figure here, and I think, okay, I'm going to go clockwise, I'm going to rotate it. If I rotate it, I'd get something like this. Okay, I get that. It doesn't fit on itself yet. That's about a 90-degree turn. But let's see what happens if we keep going. I'll erase this. And I rotate it one more time, another 90 degrees. And guess what? Does it fit on itself? It does. It fits perfectly. So it does have rotational symmetry because I didn't go 360 degrees in a circle. It does have rotational symmetry. And I hit it after two turns. So 90 plus 90 is 180 degrees. So yes, it has rotational symmetry at 180 degrees. Now how about this figure? Let's think about this one. All right, if I move this figure and I go 90 degrees, after 90 degrees, my little point is going to be here. It doesn't fit on top of itself. So I keep going. I go another 90 degrees. Okay, so now I'm at 180 degrees. It's pointing down. So nope, not there. I go another 90 degrees in my clockwise direction here. So now I've done 90 plus 90 plus 90. I'm at 270. Does it hit itself? Nope. Go one more, and it does hit itself, but that was at 360 degrees. So what do you think? Does that one have rotational symmetry? The answer is no. It does not have rotational symmetry because it took me that full 360 degrees to rotate around. So no, it does not have rotational symmetry. All right, now this is fun. If you look at letters, we can look at two things. We can decide if it has line symmetry, rotational symmetry, or it has both. So we'll just do a couple of them here. So remember, line symmetry is when we could take a line, and if it's exactly the same on both sides, it has line symmetry. So this A here, does it have line symmetry? It does. It's reflected both on both sides. But does it have rotational symmetry? If I rotate it at 90 degrees, my triangle at the top of the A would be here, so no. If I do another 90 at 180, it'd be here. Nope. Do another one? No. It takes all 360, so it doesn't have rotational symmetry. So this one just has line symmetry. All right, let's see if we can figure out one that just has rotational symmetry, but not line symmetry. How about S down here? If I draw this line right here, they're not the same that direction. If I take my other line here, nope, they're not the same that direction either. So that doesn't work. So they don't have line symmetry. So it's no, it's not in the middle. We know it's not here. But does it have rotational symmetry? Will it hit itself? All right, so I'm going to take this little point here. If I go 90 degrees, that point of the S will be there. And then if I go another 90 degrees, I'm at 180. And look, it does. It fits right there. It has rotational symmetry at 180 degrees. So it didn't have line symmetry, but it had rotational symmetry. One that fits in both. Let's see. How about the letter O? If I throw this one here, the line here, so let me move it here. Yep, it's the same on both top and the bottom. Okay, so it does have line symmetry. And if I put my center point right there and I rotate it, is the O going to hit itself? Yeah, absolutely. The O hits itself right at that 90 degrees. So it does have rotational symmetry, so it has all three. All right, the last one that I want you to look at and think about for yourself is how about, let's go with letter B. All right, look at the letter B. and we're looking at the letter B that's written out here. Does it have line symmetry, rotational symmetry, or both? Think about it for a second. If you said line symmetry only, you're correct. It has line symmetry because I can take my line and draw it right through the middle and it fits. But does it have rotational symmetry? No, because if I go 90 degrees, my two bumps would be right over here. I go another 90 degrees, they'd be down here. And then another 90 degrees, they'd be here. They never actually fit, so it does not have rotational symmetry. It just has line symmetry. And that concludes today's lesson 4.2.